Okay, so we will try to create a small dynamic analysis. First of all, let's open on the beginning the shell design geometry. And let's create a small structure. First of all, I'll create the access system for it. It will be a truss bridge. I will go for 0, 2, 4 and 0, 0 to 5. I will click apply, and I will create also the bars. I will use IP 400. I'll track. Okay, so now we have a bars. I'll move it, and then to quickly do the three-dimensional bridge, I will just copy it to the one side. But also I will imply transverse beams on the bottom. Okay, and then what we need is we need to left side and make the mirror, which is called vertical mirror. I will check the point of mirroring. Okay, so the bridge is almost prepared. I will go for the boundary condition, which will be support, the pint. Okay, the model is almost ready. The only thing which I need here, or what I need here, is to check the natural frequency of the model. To check that, I will just check the deformation. If everything is consistent, everything is okay. I will go right now for the model analysis. I will go for the analysis type, click new and model. And what I can find here is the number of modes. The number of modes, it's of course limited to our number of degrees of freedom. So this cannot be higher than the number of degrees of freedom. What else is important here? To choose correctly the mass matrix definition. It can be consistent or lumped. We will try to compare both methods. So modal lumped here, NTNU modal, okay, modal consistent here. Both of them has got 10 modes to calculate and 40 iterations. The analysis should be pretty fast. And how we can check the modes? Here we are going to the load definition modal lumped, and here I go for deformations, but here I have to choose the mode which I want to observe. So now I see it is mode number 1, and the whole bridge is vibrating in the Y direction. Let's see. Yeah, there is almost no vertical movement. Everything is in horizontal. And this is for the lumped, and the value is 0.74. If I go for the modal consistent analysis, it's 0.75. So it's almost the same. But let's check the other modes and the values. To do that, I will go for results, advanced, and model analysis. Here I can compare, for example, for the modal lumped. I see that the first mode is vibrating in the Y direction, so I can easily say that this is our horizontal vibration. I can also see that there is also nothing, almost nothing in percentage vibrating in the Z direction. This is why I have to check more modes than just 10. I will check also the consistent and type of the analysis, and I see that the values of the relative mass has changed, but not so much. Let's see that for the 10th mode, it's 462, when for the lumped, it's 379. So for the lumped, it's a little bit smaller, but for example, the first mode, it's almost identical for the both. At the second, it's already quite different because it's from 152 to 161. Okay, so what I have to do now, I have to go for the parameters of the modal lumped and increase the number of modes to 20. We will see if it's enough or not. And also I will do the same for the consistent. And we are looking for the vertical vibrations in our bridge. Let's see. In the consistent type, we see that 19th and 20th mode, it's 82% of mass vibrating in the Z direction. Let's go for the lumped and check if it's the same. Oh, here it's a little bit different. Even the 16th mode, it's already vibrating in the Z direction. Let's check how it is looking. So for the consistent, we know that the 17, it's still horizontal, but at 19, it's vibrating in that direction. We can control the value of the formation scale by clicking here normalize. And now we can see it a little bit better that 18th, it's still horizontal, but the 19th, it's already vertical. And the first vertical frequency then, it's 15.51 Hertz, which makes pretty high to make it dangerous in the vertical. I'll go for lumped and see if it's the same. Here I see that mode number 13, it's still horizontal, but 14 still, and 15 still, 16, then 16 with 1551, it's already vertical. So one more time, I can also check it here on the table that it's 1551 for the first vertical vibration for the modal lumped, but the modal consistent 1551, it's the same value, but as we can see, the consistent method found more horizontal modes in between 0 to first vertical one. Okay, this is all about the model.